Hello, this is a short demo video for the Wildlife Protection Game, or WPG for short, which is an artifact for evaluation of antifragility for autonomy in adversarial environments. What we see here is the WPG visualizer. However, the Wildlife Protection Game was designed to be run headless so that we can run multiple simulations. So the data gets recorded, we start from the command line, and then the visualizer can be used to replay what happened during the missions. So the easiest way to get started is to just run a single mission with the WPG command and no additional arguments, and that will run a mission with the default configuration. We see here what in the log what mission strategies were used and that the mission ended in success, and we see a measure of effectiveness that was computed for this mission. Since it was a single run, the visualizer was opened automatically, and we can use it to replay what happened during the mission. We can see that the drone went to the area of interest, found the poacher, tracked the poacher, and returned to the base. When we run a simulation, the simulation data gets recorded in that outputs directory. There are different CSV files that have data of what happened, and there's that log file too. Now, to evaluate antifragility, we usually want to see what happens when the poacher behavior changes, to see how antifragility deals with that. And we also want to run multiple simulations to do some statistical analysis. So to do that, we use this multi-run option. We have to tell how many runs we want, or in this case, we want to have 30 runs. And for reproducibility, we are going to fix the seed so that then we can run other simulations using the same random seed. So we'll fix that. And with the base autonomy and the base poacher behavior, the autonomy is able to always execute the mission successfully. So what we are going to do now is to say that the poacher behavior should be a different one. We are going to select behavior number 2. While I run that, the 30 simulations running, behavior 2 means that if the drone gets too close to the poacher will hide under a tree. The data gets recorded for each of those simulations, so we provide a tool, WPG-exp, that will consolidate all the data from different runs, and it has an option to print a summary of what happened during those missions. So we are going to execute that, and we see that out of the 30 runs, 24 of them were successful, and the drone was lost in 6 of those missions. The reason is because the base autonomy didn't account for the fact that it could take too long to find and identify the poacher. But with this new behavior, the poacher can hide, and therefore in those cases the drone ran out of battery. So now what we want to see is how an improved autonomy, that in this case we have improved manually, but when evaluating an anti-fragility approach, the anti-fragility approach would improve the autonomy. We want to see how that performs. So in this particular case, where there's an option for the adaptation manager to tell it what strategies to use, and they are in JSON files. So we're going to tell it to use strategies 2.1, and we'll execute that. The simulations are running. It's the same poacher behavior that it's able to hide. Now we're going to see the summary, and now we see that out of the 30 runs, the mission was successful 27 times. In 3 of them, the poacher was not identified, but no drone was lost because this new autonomy has a feature to return to base before it runs out of battery. There are many different options to configure WPG. They are described in the documentation, but that's for now with this demo. Thank you for your attention.